what we did in the last couple of videos leads us to this parsing functions. So you have an infinitely long number, and what you do when you have a linear space with an infinite amount of numbers is you integrate them to one function, one equation. Okay. So what you can do is break up the equation into parts and map those parts on the linear space 2, and they would just add up to each other. So you might see a polynomial, which is like an S, and then you might see a bell curve, and you might have that in one. You might be able to just have that in one equation. Anyways, what you would do if you were parsing functions, if you were parsing the numbers within the function as well. So if we reached at 74747, we could fill in this endpoint at 3 decimal spaces and still have the 47 left over, which is an infinitely amount of, so it'd be 0.0474747. So this remainder is is very minute to this equation here. It only means so little. It only means so great. It's just so very fine. But it also can be treated as a serial function. And that means that this value has a notional value. When it has a notional value, you have to find out a way to compute it into the function again. So if you just had simply an S curve, let's say an S curve with a peak and a minimum, you would find that the peak limit is where the change is 0. So you're going to have your first order derivative and your max min there. But you know that that's at 0.5 because it happens to be half a bell, or it happens to be the continuous probability function, or it happens to be like a high band pass filter. So you know that is going to be at minus 3 decibels or something of 3 decibels. And but it doesn't necessarily mean that that's the exact number. But so that this is a minute change. What we're talking about here with the decimal places, this 47 can be called into a different function. So it will become 0.00 0.000047 0.00047 instead of 74747. And then we're adding that into that becomes epsilon f of x at 0.747. So in other words, what we can do is we can integrate this function. So why don't we do that? Why don't we integrate the bandwidth function? What you see is that let me see if it is here. I'll have to do it. I'll have to do it here. So minus 1/2 2 to the power minus 1/2. So you have, I was right. So it's 1 over square root of 8. Not that that means anything, but that's what's integrating this function. I don't know what it means. And this here is no longer epsilon. So it should be adding it into, it's becoming integrated like that. So it can be a remainder of a different function, depending on how many decimal places you have. So in the case where, I'm performing NASA almost level math, you know that your serial 747 is going to be good because it's a long number. And not just 747, it's 7474747. So that's how we meet, because if you don't have 47, then you don't have any 747 for me. Okay. And so that's how it works.